Oh, I think Ryan's frozen.
It's saying host has disabled screen sharing.
Oh, okay. Sorry. I think that's because he left. Give me 1 second. Sorry about that.
Sorry, I'm here, but
I
can you hear me?
I can.
Okay, great.
And you should be shared. You're able to share now.
I can share now. And sorry, I seem to be having some computer issues. So if it's breaking up, maybe Kelly can just share the slides from his screen if that happens. But I think, yeah, I'm going to hand it over to Lisa, who's going to kick us off here.
Okay, thanks very much, everybody. Hopefully everybody can hear me. So I guess, Ryan, you're managing the slide deck?
Yeah.
Perfect, okay. So this is a really exciting day for us because this is really the last workshop and the end of this particular contract that has been funded by the Atmospheric Fund. You can go back one, Ryan, yeah. And we've had several workshops in the spring that some of you might have attended. We had over 300 people attend where we were getting, vetting and getting input into this study. What we want to do today is we want to talk to you about the policy primers, what we're calling it. So that's the final deliverable in this TAF contract, which is for Ontario. So it's really something that gives you the nuts and bolts that you need to be able to understand what embodied carbon is, how we need to manage it, and sort of the best tools that we can use to do so. You have a bit of a Q&A and a breakout session, so we do want to get your feedback into this final deliverable before we provide it to TAF and before we release it. So that's the idea of today's meeting. Next slide. Are we frozen?
See if we're frozen. You know what, Ryan, if you could just email it to me, I'll take care of the slides if need be.
Okay, anyway, just a little bit of context from me before we hand it over to the leaders, the consultants who have been working on this. Many of you are familiar with the Toronto Green Standard and you're working on your own green standards, which is fantastic. So we're in our 4th update of the TGS, we call it, and it was approved by council last year in July of 2021, but came into effect May 1st of this year. And what we did was we incorporated our first embodied carbon tracking requirements into that standard. We did that in tier 2 because you'll recall that our standard has multiple tiers in it. So tier 1 is the mandatory, tier 2 is the voluntary. And under TGS before, we actually have 3 performance tiers. So we have a tier 3 as well. And with respect to our energy and emissions requirements, that tier 3 is near zero emissions. And of course, we implement our TGS, the mandatory requirements through site plan control primarily. So using all the documentation of site plan control to demonstrate compliance. But for the voluntary tiers, we have a separate verification protocol that happens after SPA that's handled by third-party verifiers, but it's our protocol. And so that's when you would see various types of submittals right out to occupancy as proof of compliance. And then we offer that development charges refund for those high performance projects that are verified and certified. So just as a little bit of background and reminder for those of you who are familiar or less familiar with TGS. So next slide, please. Something else you should be aware of if you're not already is that we had an approved 2030 trajectory for near zero emissions operational energy and emissions targets in the TGS. So it was approved in 2018 by council. But in 2021, City Council, through our climate change action plan, which is called Transform TO, that process, they actually asked us to accelerate that trajectory sooner. So that by 2028, instead of 2030, our highest level, like that tier 3 that I mentioned, is the tier 1 for all new construction. So that means that all new buildings have to be, as mandatory, built to very low emissions levels by 2028. And we have a set of metrics that we use for that. But as part of that, we also knew that because we have high energy and emissions requirements on the operational side, we knew that in TGS version 4, we would need to address embodied emissions as the next big piece of reducing carbon is what we're more focused on, but carbon in new construction. So I just wanted to point out that's our kind of time frame that we have to implement. Also just mentioned to you as new news, hot off the press, that yesterday City Council approved our increase in the DC refund. So we're pretty happy about that, which provides a higher level of refund for tier 2 and 3 projects. So that's really exciting for us. So that will help to facilitate getting more of those buildings, those near zero emissions. Next slide. And so this is just a quick snapshot of what we had included in the TGSV4 that was approved by council around embodied carbon in building materials that we'll be talking about. So we started off with in the tier 2 and tier 3, addressing what we call upfront materials emissions. So a report has to be submitted, an LCA, which Ryan will explain to you. And we're mainly referring to the zero carbon building standard methodology for how to do that for big buildings. And for low-rise buildings, we've been working with Chris Magwood, who's undertaken a study, and we set an actual target. But again, these were voluntary. So voluntary targets and submission requirement of an upfront LCA. And then in tier 3, we're asking for a larger LCA for those projects that are near zero emissions. So that addresses all stages of the building life cycle, and an optional target there of a 20% reduction, which is as per the zero carbon building standard optional pathway that it had. So it's aligned with that standard. Next slide. And so these are the 2 studies that have been going on, supported by TAF, that really help to set the benchmarks and baseline for how do we set targets on reducing embodied emissions and materials for new construction in Ontario. So Chris Magwood's study, Passive Buildings Canada, is already released, the low-rise housing study. So you should have a look at that. It's a great resource. And then the second study that we're completing and we're talking about today is related to part 3 buildings. So the big buildings, mid to high rise, non-residential. So the low-rise study really deals with a separate type of construction. So it's got different numbers and benchmarks and outcomes. So with that, I'm going to pass it over to Ryan and the team to talk about the final results and what we've included in the policy primer to get your input. And thank you so much for your inputs today.
Okay, hopefully this is working. I just logged in for the audio through my phone. Can you guys hear me?
We can.
Okay, great.
Yeah. It goes to show you that virtual meetings, technology always has its challenges, right?
Okay, I think I got it now. Sorry about that.
I think we have 2 of you coming in now. Okay, no, you seem to be okay, because I see.
Is my audio okay?
Yeah, you're good.
Okay.
Take it away.
I just got a brand new computer and I thought that would make things smoother, but apparently not. So sorry about that, everyone. So yeah, this is the overview of the contents of the primer that we are looking forward to releasing very shortly. So we have broken it up into into 2 main sections. So the first section is really about the importance of this issue, why we want to be managing embodied emissions, and or what the recommendations are. So we're going to go into some details into that in the following slides. But we think it's very important to also provide some guidance on how to do that more specifically. And so that, because there are many ways to do life cycle assessments, many things you could include or exclude, different life cycle phases you could include or not, different parts of the building you could include or not. And we found that currently everyone's kind of doing this slightly different, and there's not the level of guidance on that to have consistency across the assessments. And we really need consistency across assessments to be able to benchmark and set targets and set appropriate reductions and comparisons. So that's why we think we go into quite a bit of detail there, but we think that's all extremely important and critical for high level comparisons and benchmarking. But we didn't want that to get lost in the recommendation. So that's kind of why we broke it up into like a part 1 and a part 2. So, and again, as Lisa said, and Gabby said, we're really looking forward to any feedback that that everyone on the call has about how we might be able to make this more clear. So please, if you have thoughts, write them down and share them with us during the discussion and or afterwards via email. Next slide, please. So the first major part of the work that we did was to go out and benchmark and to collect the data that has already been calculated out there by folks who are doing this type of work. We received 41 responses back from 41 separate projects, and for part three, large buildings. So I should make that clarification that there was a second study that happened kind of in parallel with ours, that was led by Chris Megwood and the Endeavour Centre and Sustainable Buildings Canada. So they had a slightly different approach where they actually did their own assessments on some archetype building plans that they received. So their results are shown in the first column here. You can see in the caption there, it says Part 9 residential small and 503 buildings. So that was the separate study done by Chris and his team at the Sustainable Buildings Canada team. The other three columns are the self-reported results that we collected in our Part 3 study. So for the primer, because we think that most municipalities in Ontario are going to want to have all of this data, so we've kind of included them all together in this primer. We didn't only focus on the Part 3 results of our study. We also brought in that parallel Part 9 study. So all that to say, we have a very robust and representative numbers here for both Part 3 and Part 9 in the results that we're sharing now. So you can see in these results that the Part 9, the smaller residential buildings, are significantly lower in terms of the embodied carbon. This makes sense because it's mostly stick frame construction, smaller frame wood construction, timber-based construction, whereas the Part 3 larger buildings, both residential and commercial, retail and other, that has a lot more concrete and structural steel and these materials that we know are higher embodied carbon. So that makes sense. And you can see that the ranges are quite larger in the Part 3 buildings as well, which again makes sense as they're very unique. And these range from hospitals and large courthouses, things with a lot of security concerns and additional materials, and down to warehouses. So there's quite a range in the Part 3 buildings, but this is the first time that we've had any benchmarking across Ontario for what these value, what an average value might be, what a high value might be, what a low value might be. So we think that this really will help unlock a lot of decisions and hopefully good policy going forward. So we can go to the next slide, thanks. So what we did after we got these results were we thought about what would be some reasonable caps to put on these types of construction. So you can see the red, those red bars that are superimposed on top here. These are our recommended initial caps, and these are still being massaged a little bit, so these numbers might change slightly, but we're pretty confident that these seem like reasonable caps right now. We're kind of walking a fine line between obviously trying to reduce emissions, trying to drive change, but also on the other hand, not trying to trying to minimize pushback from the industry. We don't want everyone to have to completely change all their processes and supplier networks and supply chains and all of that overnight. Obviously, we need to have this be I don't want to say a gradual change, because we are in a climate crisis. We do need to make significant action, but we also need to bring the industry along. So we're trying to find that medium level where we're making real change, but not making it extremely difficult to build new construction. Obviously, we have an affordability crisis and other issues, so this all has to take that into consideration. But we think these caps are reasonable. Most of the benchmarking that we've been doing, or the numbers that we've received that represent the benchmark, those projects didn't really actively try to reduce their embodied carbon. Most of them, it was just about calculating what they're already doing. So we know, in fact, that there's quite a lot of low-hanging fruit available to project teams that get serious about trying to reduce their embodied carbon. There's a few key changes that you can do, and we've demonstrated that with the City of Toronto on this project. There's a handful of material substitutions you can make that don't cost extra money, don't impact performance, and they can significantly reduce emissions on the order of 20–30%. So we think these caps are reasonable, and people will be able to meet them without too much difficulty. Next slide, please. So The initial caps, we're suggesting 2024 here, but again, these are just recommendations. They're going to the timelines and other things like that will have to be. We'll have to consider the local context of the municipality, but we're suggesting that within a two-year window, two-ish year window, we should be able to have these caps, or earlier, but within 2 years, we should be able to have these caps initiated. And what we're proposing here is to half the cap by 2030. So the best climate science now is saying we need to reduce emissions by half by the end of the decade. So that's the guidance that we're implementing here. So you can see we've recommended the cap gets to half by 2030, and we've put in a few interim steps here. And again, the interim steps maybe 4 steps is too much. We're suggesting every 2 years, but maybe it's every 3 years, or maybe it's maybe just 2 steps. But that might have to be massaged based on the municipal regulation cadence, or update of the standard cadence, or things like that. But we think, again, trying to balance between bringing the industry along and not having one key date where things get extremely hard for the industry, but have slowly and surely improvements to half by 2030 is kind of what we're recommending here. And another thing to note, in the caption there for the table 1 caption at the end, it says life cycle phases A1 to A5. So just to speak to that a little bit, that refers to upfront carbon. So this is everything that happens up until occupancy. So A1, A2, and A3, that's all about the material manufacture, the harvesting of the raw material, the transportation to the manufacturer. And I'm just think I have my ceiling on my camera video. Sorry about that. Turning off that extra video. Sorry, the raw material manufacture, and A4 is the construction, the transportation to the construction site, and A5 is the actual construction process itself. So we're recommending to include all of that, A1 to A5, which is, again, the upfront carbon. It's the vast majority of carbon. Our study and other studies have shown that the upfront carbon is somewhere between 80 and 90% of the total carbon footprint of the whole life cycle. So we're not proposing to include here the use phase, which is B, or the end of life phase, which is the C phase. All of those happen out in the future. There's a lot of uncertainty about what carbon emissions would actually be in 20, 30, 40, 60, 70 years, where these life cycle phases are applicable to, and it is a minor part of the total life cycle. So we do recognize the importance of the future life cycle emissions, and we would ideally want those to be included into policies like this in the future. But again, in interest of making this a manageable policy to implement, we're trying to kind of simplify things a little bit. So we're just focusing on that A1 to A5. And we can go to the next slide, please. And sorry, Kelly and Lisa, if you have anything that you want to add as we go, just feel free to jump in, but I'll keep going if not. So in terms of the life cycle phases, so I was just speaking to this, sorry, I should have spoken to it on this slide, but this just shows those life cycle phases with all of the names. And you can see the red dotted line there, that's our proposed subset of our system boundary. Again, this is called upfront carbon. This is everything up until occupancy. Just to note, the national, the NRC, the National Research Council's national guideline for whole building LCA. This image is from that document. And just to note that the red subset is not in the document. Their subset you can see is the gray dotted line. So we are proposing a subset of the NRC's guidance, just to, as I said, to make things a little bit simpler and focus on the biggest piece of carbon that we have the most control over in procurement. But ideally, we would like to expand out to those other life cycle phases in the future. We can go to the next slide. So the other big thing to make sure that folks are consistent about when they're doing these assessments so that we can compare results is what's called the object of assessment. So that means what parts of the building are we actually including in our assessment. So we are following the recommendations of LEED and the CAGBC right now, which is basically to focus on the structure and the envelope, but we've kind of just spelled this out a little bit more with a little bit more detail, and we've changed the wording a little bit to call that the simplified scope of assessment. You can see on the left, which would be a requirement that all projects we need to report their results of the simplified scope or the simplified object of assessment. But we've we've seen and heard from clients, including clients that I've worked with, who have said, we don't want to just limit our assessment to that. We want to be more holistic. We actually want to know our full carbon footprint. So we want to include our mechanical systems or our our parking lot on the site. So LEED specifically doesn't ask for those things. It asks for those things to be excluded. So the way that we're and the problem is when some people include those extra things that they want to, then we can't use their results to compare against people who don't do that, right? So that's why it can get complicated. So our approach here, or our recommendation, again, is that everyone needs to report their results using this simplified objective assessment. And if they want to add more systems, then they report a second result with that and what we're calling the expanded objective assessment, where they would have the simplified version, simplified objective assessment, and add any additional systems like the mechanical system, the electrical, plumbing, parking lot, and report those results as a separate number. Because then again, we can use just the simplified subset for our benchmarking and comparisons. So I think we can go on to the next
just to
slide.
mention that, sorry to interrupt, Ryan, just that these assessments are conducted by consultants, usually energy consultants or sustainability consultants. Architectural firms will undertake these life cycle assessments. So really, in the things that Ryan's and Kelly are recommending in this primer, it's how to do the assessment to have the biggest impact in Ontario on embodied emissions, and setting out those parameters, so that they know how to do it, and so we get consistent results. So just to reiterate that.
Yeah, and I should say that this is only the new materials in a project we are recommending to be part of these assessments. That might sound simple, but the reason we want to make that distinction is because if people are reusing anything on the site, if they're reusing the structure and just doing a renovation of the building, or even if they're bringing in salvaged material from another project and applying it to this new construction, they should be given an incentive. They should be incentivized to do that, right? We want to incentivize reuse. We want to incentivize salvaging and reuse of new buildings. So one way to do that would be for people to, only including new materials. So any of those things that they salvage would be a 0 on their embodied carbon assessment, and it would help them achieve these caps easier. So just want to make that point. We can go to the next slide. So another thing, and another one of the big pain points in the industry that we heard was sometimes folks are asked to provide embodied carbon assessments early in the design stage, where they don't have full information about what the ultimate design will be, what the ultimate supplier will be, what materials they're going to select. So there has been a bit of a mismatch between when people are asked to give these results and the data they have to actually do the results. So we're proposing to use the approach that we use for cost estimates, which is, we all know about a Class D cost estimate versus a Class A cost estimate. So we want people to start thinking about these carbon metrics similar to how they think about cost. We know we don't have complete information about cost at early stage of a design, but that doesn't mean we don't make decisions based on those numbers, right? We have to make estimates, have ranges, and be confident to make decisions using those values, knowing that they're estimates and they're not going to be 100% correct. We have to have the same approach with LCA. So we're proposing this language of Class D to Class A estimates to be applied to LCA, and in this table we're just providing some recommendations of where those may apply. So for example, Class D LCA estimate would be reasonable at the conceptual or schematic phase. And at that phase, you could make decisions based on that result, based on that model. You can make decisions around amount of underground parking, for example, right? If we reduce the amount of underground parking by a few layers, how much of a carbon saving does that have? These are the types of decisions we can make at schematic at early stage, or things like the main structural material we're using, concrete versus steel versus timber, or how much of the material we're reusing or salvaging. Things like setbacks, right? High level things like that can only really happen at this early stage. It's not appropriate to make those decisions at tender documents because it's too late to make those decisions. Similarly, at Class C would be at earlier design or through design development, and we can have more insight into things like, what cladding materials or window to wall ratio we're using, what insulation type, what's our floor plan, how many interior partitions are we having. maybe what kind of concrete types or strength classes, right? So again, these are all decisions we probably wouldn't make a conceptual and probably wouldn't make a tender either. So there's key points within the life cycle phase or the design phase where we have to have a model to help give us results on making better decisions for some of these things. Moving down the list of class.
I'll just add into Ryan to what you're saying on this slide is just that you can also think of these stages as how they align to our approvals processes. So the class D, that stage conceptual design aligns with rezoning, and the class C design development is what we think of in terms of SPA, where we get all those detailed drawing sets for all of us municipalities. And then the B and A are more aligned with the building permit process, going out from first at grade building permit out to final building permit at occupancy stage or post occupancy. And so for our tier 2 voluntary level that I mentioned before, our requirements that we have in the TGSB4, we have our verification requirements aligned with those stages, the permit stages, the tender documents, and the completed construction as built in terms of what the submittals would be and what they'd provide.
Thanks, Lisa. Just to finish down the list, Class B, that may be appropriate at tender or for construction documents. And this is where maybe we can think about more about the specific suppliers. How far are the materials being shipped from? Maybe we can start thinking about using electric vehicles for some of our deliveries or construction processes, and things maybe more specific details about the actual steel or in concrete and wood properties. You know, what are the mixed properties we're using? And then Class A, that may be an as-built model, right? A post-construction where we can actually confirm all of these values that maybe some of them might have been estimated earlier. So we think that this approach of Class D to Class A can be quite valuable and provide a lot of insights to project teams. And we would recommend municipalities to ask for, you know, early stage LCAs, maybe call it Class D estimate, and say, you know, these are the types of things that you can decide at that level, and these are the kind, and give some reassurance to the people that you're asking of these studies from, that you know these are estimates, right? Because we've heard some people like get afraid of, we don't want to put a number in here or a value in here because we're not 100% sure that's what's going to happen at the end of the day. But we need to make these estimates to improve over time. So we recommend this approach here, and would be happy to take any thoughts or suggestions. So we'll go to the next slide. I think we're almost done here. Yeah, as Lisa was saying, that we've also suggested some potential links to building approvals. This again is going to depend on local conditions and what processes you have in place and timelines that you have in place. But there are 2 examples here that you can point to already. Lisa spoke to this first example that the City of Toronto has already implemented. Rezoning, they are now asking for a preliminary LCA. I might call that a Class D LCA to be submitted along with the energy strategy report. So that's already being asked for. And then for their Toronto Green Standard Tier 2, which is that voluntary higher level, they are requiring at occupancy a full LCA report, which maybe that's a Class B report based on as-built documents, or maybe it's as constructed Class A. And then they are looking at adding this to site plan approvals as well. And then we did also in the primer show what Vancouver is doing. We know that this primer is for Ontario, and Vancouver obviously isn't in Ontario, but we think it's still an important data point for folks to have and a precedent that they can look to. And we can go to the next slide. And then finally, we proposed a reporting template. We think this is very critical to have people use a consistent way of reporting these things. I won't go through all of this. I'll just point out a few key pieces. One is we're asking for about in the 4th or 5th line down there, it says above grade stories and gross floor area, and below grade stories in gross floor area, and then total. So we're asking for people to break out, you know, what construction is above grade, what construction is below grade, and then what's the total sum of the 2. And this is because through a lot of Kelly's research at U of T, we found that below grade construction is actually significantly higher carbon than above grade construction, which again makes sense when you think of all of the retaining walls and additional concrete and steel that we typically find below grade, and XPS insulation, which is the typical insulation for below grade, is very high emitting. So we think this is a new thing to ask for, is the split between above and below, and we think that will probably help unlock a lot of opportunities to reduce in the future. The other thing I'll point out is on the second pane here, you can just see the results are being broken down by life cycle phase, and we also have the simplified scope for the first two columns there, and the expanded scope for the last two. And it's just that where that red box is, where the mouse is beside, that is the value that would need to be below the cap. Right, so that's the total upfront carbon, the sum of A1 to A5 of just the simplified scope, and it's the intensity value. It's the total carbon per meter squared. So we're asking for a lot of data here. We think this is all good to track for the municipality to make better data, to make better policy in the future. But that would be the one key metric in that red box that we would require to be below the cap. I think we can move to the next slide. So that's it from us. Wanted to hand it off maybe to Gabby to talk about the breakout sessions now.
Yeah, for sure. Thanks so much, Ryan, Lisa, and Kelly. I really appreciate that. We're going to have a little bit of a Q&A time period before we go into the breakout session. So there are a few questions already in the chat that I will raise with you all. And then if there's additional questions, please feel free to put them in the chat. You can also just raise your hand and I can unmute you, or you can unmute yourself, and I'll call on you and you can unmute yourself, and then you could just ask your questions verbally. But one of the questions that came in, where is it? I'm here, just pulling it in. It is related to how much difference do you guys think that there will be in the embodied carbon calculations across the country in terms of different provinces and territories? Is this something that's going to vary across the country, or is it something that is that can be, like the research that you're having here, is it transferable to other provinces?
Great question. I think that there are certainly regions, there's fluctuations, but they're fairly minor. Climate's a big driver. So I'd imagine further north, you'd probably have higher carbon intensity, just to more insulation, etc. Maybe. But by and large, I think the numbers that we're showing track to the numbers that Vancouver in the similar benchmarking exercise that they've done, and also numbers that we've seen in Europe and similar kind of climate zones. So I don't expect there to be that much fluctuation across provinces.
Yeah,
and
I agree with
the subtext would be, sorry, Ryan, the subtext is these numbers, like this work is confined to Ontario municipalities with this grant, but certainly I think our hope would be it is transferable, and we see this not just being limited to the Golden Horseshoe or Ontario. Sorry, Ryan.
Yeah, no, that's great. I was just going to agree with that and say one thing this is much more, I think, applicable for consistency than operational carbon, because operational carbon, as you guys know, relies on the electricity grid in provinces which vary widely, which this doesn't have that same level of range, I guess I would say. But the thing to also be aware of is that a lot of the results now are using data which may be industry average data for like concrete across Canada. And as we get better data over the next few years, as we get Ontario specific results and Vancouver specific results from the plants in those regions, the data might start to separate a little bit more as they take into account things like the local grid that's used in manufacturing materials. So that's not fully captured in the data right now. But I agree in general that it is that the results should be more or less relevant across the country with those caveats that can be said.
Okay, perfect. And then just a little heads up, there was some questions with regards to whether this is only for new builds or whether it's also for renovations. And Kelly just put into the chat that it certainly applies to new builds, but it would also apply to renovations as well. So it's something that can be available. Oh, go ahead, Kelly, take it away.
Yeah, just to add, I mean, the thing is, if you're doing adaptive reuse projects, it's gonna be a lot easier to hit the targets because those emissions exist. And in a way, I think as an outcome of these targets, I think it'll encourage more reuse of the existing building stock.
Fingers crossed on that one. That would be amazing.
And or materials.
Yeah, and all of our benchmarking was for new construction. So if the building is if the there's a renovation and they're reusing part of the structure, they're going to be well below the cap. So it might make sense to even make, you know, caps for renovation down the road if because we want to drive performance everywhere, not just in the new construction.
Yep.
And what is going to be done with materials without EPDs? Are you suggesting default values for the methodology? Like if you don't have the environmental product criteria, how do you bring that into it?
Yeah, so we have a call out box at the end of the primer that is areas of future research that need to be done. And that is one thing that I think we all agree would be very valuable, is to have some default values for Ontario, that if you don't have an EPD for your product, here's a good you know, default proxy value for an Ontario manufacturer. We don't have that yet. What is typically done is people would use the next best, the next closest material that does have an EPD, or a national average EPD from an industry association. So, but that is definitely a place where some more work needs to be done.
You know, and add to this, it's a bit chicken egg, where, you know, by requiring LCAs to be done, the manufacturing sector, this is encouraging, incentivizing them to do EPDs, right? So where they don't exist, let's hope that they do exist in you know, shortly. And the manufacturers that we've talked to in this process, and even outside of it, you know, they see the benefit here. Doing EPDs will make their product that much more marketable, one, but more importantly, it's going to have them look at their own supply chains and figure out how to make their own products greener, right? So that's a real intended effect of doing this. And you know, I think that will be a positive spin out of this, is that, you know, Toronto being first out of the gate, you know, or say very much leading this as an industry, that will bring, I think, Canadian manufacturing along with it and be something that could lead in North America and beyond.
Great. And can you speak to the industry knowledge readiness? Should we ask for the REES reporting requirements in future applications? For example, if a simple life cycle analysis was required, how much support or resources may be required to supply this information? Which additional capacity development support, what additional capacity development support would be required?
You want to feel that one, Ryan?
Sure. So in terms of the industry can do this, that was one of the key takeaways we had. You know, we asked for results and we got 41 projects back, and that means a lot more people are doing it if we got 41 back. It is a new area for some, you know, for some folks, but all the big firms know that this is going to be standard practice going forward. Folks like Perkins and Will, the large architecture firm, they're just doing this across the board for all their projects now, whether the client asks for it or not, because they understand that this is the way the industry is going. They want to have the data. They want to have, you know, data benchmarks of their own to point to. So we're definitely seeing a very quick evolution of this, and I wouldn't be afraid to ask folks for this. They might say, we haven't done this before, but if it's not on this project, it's going to be the next one, or it's going to be the next one, right? This is where the industry is going. In terms of the key thing, the key difficulty in these assessments, or the thing that takes the most time and effort and cost, is to get the material quantities. So just to put that on everyone's radar, if there's a way that we can start collecting material quantities in a simplified manner, that makes the life cycle assessment much quicker, because that's the main input we need to put into the data set, or the tools we're using. It's how much concrete, how much steel, you know, the quantity of these key materials, and then finding the EPD that is most representative for those materials. So things that we are using in our practice is cost estimates, right? So there's a lot of, most projects will have a cost estimate breakdown, and they'll actually be quantities of each material, because they use that quantity for their costing purposes. So we're asking all of our clients and all of our projects to make sure that your cost estimates have quantities broken out per material, and then we use that as a main input for our LCA analysis. The other tip would be, if people are using BIM modeling, 3D, you know, building integrated modeling, those 3D models can very easily spit out quantities if you set them up from the start to do that, right? So sometimes people make estimations and they might not model the profile correctly. They'll just do a rectangular box to represent something. That then we can't really use it to get the quantities. But if people model things accurately with the right shapes and the right volumes, then we can easily get the quantities from that.
And then out of curiosity, is that in terms of the the research kind of provides the methodology and everything, but is there going to be a corresponding, let's say, calculator that can be used, or some sort of tool that can kind of aggregate all this data across the different developments? Or is this like you're providing the methodology to the developers and then they submit that's to like, the goal is they submit this as an part of their full development application? Just wondering how there might be some possibilities to have it so that it's not just a paper submission into a municipality, but that the data could be aggregated. Is there some thinking, have you guys given some thought to like a calculator, a tool that can help to pull this data together?
Yeah, so there's tools out there. There's some that are that you need licenses for, and there's some that are open source. There's the two big ones that I think for the responses we've got, and certainly I think the tools that we've been using and Ryan used are either One-Click LCA or EC3, are the two kind of the biggest market shares right now. One is open source and the other one is not. There's Athena as well. They're data aggregation tools, basically, right? That associate quantities to EPDs and then bundle that together and give you totals. The methodology, and I think the template that we're showing is in line with what with NRCan, what they're doing to kind of harmonize this across the country. So this is following best practice and not just in Canada but internationally. So that it's a fairly clear methodology, and there's tools out there, and they're not cost prohibitive. One of them's free, and frankly, it's kind of just diving into it and getting familiar with it. It's it might look a little daunting right now, but either reach out to folks like Ryan and myself if you've got questions, certainly following up, but and I think follow the advice that Ryan just gave as far as how to tie this to quantities and costing. And I think within from an architect's perspective, doing this in a design phase will identify, hey, here are some opportunities for changes, or we need to think differently about how we're the grid or the envelope. Like this analysis needs to loop back into both design decisions, but also from a municipality perspective. I think this data will begin to inform, hey, maybe there's some things in our current zoning or planning that have got real positive or unintended negative impacts that need to be, reviewed in light of this.
Yeah, and I'll just add to that the National Research Council is working on or they have an idea. They'd like to start working on what they're calling like a data exchange format, so that people can submit these results in an electronic format, and there would be a centralized database that would automatically be compiling them and comparing them. So there is a plan for at least a wish to move that forward, and the federal government has provided a lot more funding to the team that's working on this. So we think within the next couple of years, there should be a more streamlined central repository where people can submit their results to.
Great, thank
I
you.
was just going to add too a little bit here that from a municipality standpoint, like I do feel like the next stage will involve more training of those who undertake LCAs, and we might start to see that in terms of courses coming out, from CAGBC. Maybe they offer them already, I don't know. But I thought that that would be appropriate coming from Natural Resources Canada, and I'm not sure that they're going in that direction, but because they had prepared this guideline on how you prepare an LCA. So in order to get consistent outcomes, and training would be a natural next step. And then for us at the municipality at City of Toronto, we also feel it's important to train our staff on what they're going to look for in the LCAs that are submitted. And I'm not going to expect our staff to do, nitty gritty analysis of these, but, at a high level, what should they be looking for? So that'll be the other part of, a rollout that's really key for me.
Oh, that's excellent. And certainly from the training that the City of Toronto is doing with your staff, that would be really great if we could share that with the other municipalities as well, the training program that you develop, just like with the training program that you worked on with the green development standards, to bring that to city staff as well.
Yeah, and if we want to do something like that, where it's more formal program, we might have to look for partners and funding, and maybe work together on something like that as the next stage, granting.
Yep,
Mhm.
sounds good. In terms of some cost analysis with a lower carbon home, what a lower carbon embodied home would cost to build. Do you have any understanding of the current supply chains for lower carbon materials and how long it might take with to bring these supply chains up to par with where they need to be?
I'm sharing this to two things. I mean, for the homes thing, I would really recommend you go and read the Part 9 study that there's links to, because Chris speaks to this directly, that it's, you know, basically their work is, it's cost negligible. If anything, it's actually less expensive. And that at the scale of a detached single family home, it's the materials are there. I think it's mostly a design consideration, really, and a cultural change in the construction, you know. On
And
the
yeah,
larger,
sorry, just one little thing there too is just Chris also found that the Ontario like low-rise homes, like the typical practice was ahead of the curve. So that was an interesting finding. Yeah. Sorry,
And in
Yeah.
one of our workshops, one of the largest construction firms out there said that on the projects that they're prioritizing this on, they're finding a 30% reduction without cost impacts. So there's a lot.
yeah. So that's for Part 9 construction.
Yeah.
and so,
Okay, sorry.
so for Part 3, like part of this grant, if you haven't seen this previously, but you know, Lisa had the wherewithal to say, let's look at 2 of the city's own projects to understand the implications of what this policy is. So we've done a full life cycle assessment of them. One of them was the EMS station by Diamond Schmidt. This is the kind of overview of our analysis of the emissions, and we, working with the manager of that project on the city side and the project architects and engineers, we basically suggested at this very late stage of design, this is the end of design development, you know, there are material substitutions, specification adjustments in like your insulation, your concrete, your floor sealant. We think that there's, you know, a 30% reduction out there just in specs. This is not a big design change, doesn't change the dimension of the building. They went away, came back and said they're cost negligible. They don't affect our construction schedule at all. We're doing them. So I think that's the, you know, basically to reveal there's a lot of low hanging fruit, shouldn't cost any more. And simply, I think by doing the life cycle assessment, it reveals to you where the maximum impact can be had. And like, this is 800 tons of emission reductions. That's like very significant on a project of this size. And just to show the efficacy of even just doing this analysis.
Great. And I just threw in the URLs for the webinars that were undertaken to share the 3 net zero City of Toronto buildings that are up on the Clean Air Council website. That just provided the links to those recordings and proceedings as well. So thanks for the reminder on that one, Kelly. Appreciate that. Just looking for the last few questions. Out of the 41 projects you got submitted, do you know how many were done with BIM?
Pretty much all of them at this point. At this scale of building, it's the industry standard. So I'd say they, yeah, I'm pretty sure all of them.
I'm not sure if we got results, like the quantities from the BIM models, though. They might have, a lot of projects use BIM, but they might not use it to get quantities for the LCA. So yeah, not quite sure on that.
Okay. And then Chris also put another link in for another tool on in the chat as well. Yeah. So I think I've gotten the questions that were in the chat. If I missed anything, please just unmute yourself and ask your question verbally. And if you have any questions that you'd like to ask verbally, don't be shy, just unmute and.
Yeah, I welcome that. I just want to add, I realized we didn't mention the tool for low-rise construction, the Part 9 tool. All the ones that Kelly mentioned are typically for Part 3 buildings, the stuff that we looked at. But Chris Magwood's study used a new tool called the BEAM tool, BEA. So if anyone's wanting to do this for low-rise Part 9 construction, I would recommend you check out the BEAM tool. And
we put a link into the BEAM tool in the chat as well. Just other question, are there any potential risks or long-term building safety and durability that need to be considered with regards to implementing some of the lower carbon, lower embodied carbon materials?
I'll field that one. I think with the safety part, no, because you know materials have to get through all the all the safety standards to be able to be purchased and put on a building. So that shouldn't be affected whatsoever. I think that the durability piece is an interesting question. I think when we're focused on that A1 to A5 cradle to construction phase, you know, if we expand in the future the considerations, it'll take into account use and also decommissioning. So, you know, we'll see where this goes. I can imagine that gets taken into account in the future, which would look at durability as a consideration of how frequently do you need to replace or maintain something as part of that total look. But that said, right now, it shouldn't, that shouldn't be a direct result of this. Lower carbon materials are not necessarily less durable. In fact, many of the most durable materials like stone are far lower carbon than ones that are less durable.
All right, perfect. Thank you. So I think we've covered all the questions. I would, for the folks that are on the call right now, I'd love if you could actually, I'm going to assign you just randomly to a breakout room. There are 3 questions that I'm just going to throw into the chat. There is links as well to a Google sheet, but I'm just going to throw in that I'm going to send around to the link as well. So just give me 1 second. I'm going to throw in these questions into the chat. These are the questions we're hoping to gather some feedback back from you on. Are there any additional comments on the primer's content, like in terms of just general kind of additional content that you think is really important for that the primer should be able to address? And if it doesn't address it at present, it kind of identifies a next step for the research to take place. And how can municipalities apply these findings from the study? How do you think you could bring them into your green development standards? How can you bring them into your own corporate facilities decision making as well? So some of those kind of conversations, trying to understand what what you're thinking on how your municipality can apply this knowledge and this research, and then what supports or strategies are needed to effectively implement embodied carbon reductions. So in terms of actually enabling municipalities to bring in embodied carbon into their own decision making, what kind of supports do you think would be really helpful, both from your own municipal operations as well as from the development, the private development taking place within your communities as well? So those are 3 questions. I'm also going to throw in the Google sheet where we're going to have some note taking, asking people to take some notes. In addition, and just to save everybody the awkward kind of thing of like, who's going to volunteer to be the note taker, anything like that. If I could have a little bit, if you can indulge me, I'll give the person who is closest with the first name closest to A, who is going to be the note taker associated with the breakout groups. I will admit this is probably this is my revenge for all those times you got able to get out of the classrooms earlier, when they get drawn on that one. But I'm just going to make it for the first person, for the person with the first name closest to A. I'm going to ask if you could be the note taker, and then we're going to go into breakout rooms for 20 minutes, and then we're going to come back into it. I'm putting in the Google sheet for where that can be accessed, if you can use that, or if you could just kind of, if you can ideally use that for kind of keeping track of the notes, it will really help us in terms of compiling the information to understand where we are at present and where we need to go, and what are the activities that we need to advance to move to where we want to go. So I'm going to create 5 breakout rooms, and then we're going to ask you if you can go into them and discuss these 3 questions. Does that sound okay with everyone? Yeah.
I think all the A's and B's left the meeting.
As I said, the one with the closest to A. And then, if you, we will go do a little bit of check-in. If you have any questions, just come back into the main room. I'll be there to answer any questions as well, if you need to as well. So I'm going to just throw everybody into breakout rooms and send you on your way. All right. Thanks, everyone. Hey, Ryan, I guess I didn't send you, eh? Oh. You're muted.
I was thinking wasn't sure if I should go in or not because I don't want to like overtake the conversation.
I hear you.
Yeah.
I hear you. No
So I think
problem.
I'll just turn my camera off and I'll come back in when people join.
Okay,
Okay, thanks.
thanks.
policy or think about guidelines